to do it the other day, and strange things happened with my reporting, but that's good. All right, so section 1.7, linear inequalities. This is, and I kind of started talking about this a little bit the other day and then regretted that, but we're all good now, so it'll be fine. This big chart is a little bit intimidating, but I would like to put it on here for a couple of reasons. One, you don't have to have the book in order to access this. It's actually in the notes that I provide for you. But it's also just a really good setup in terms of all of the different ways we can do things. So when we solved equations, we got a value for x. So we got x was equal to 5, or maybe we got x was equal to 2 and -2, or something like that. So we got x was equal to a number. When we solve inequalities, however, we get a solution set. So typically when we solve an inequality, we might think of things like x is less than 3. Okay, so for example, but we can get lots of different things. So we actually get, when we solve inequalities, we get this piece of this, what's called set builder notation. We get something like this, and this is just the inequality statement. It might be x is, like I said, greater than or equal to a, all right? So the set builder notation is it's literally just a notation. When we solve the inequality, we get this inequality statement, and then we can put it back in this set notation. Now, don't worry about trying to write this out or whatever. This will be like a pull down menu, or you'll have something in the homework. It might look like this. It might be X, so that, and then there's a box for you to type in what you want to say, and that's where then you would type in this inequality statement. So for the homework questions, it would be something like this. For non-multiple choice questions on the quiz or the test, it would be something like this. Most of this kind of question would probably be multiple choice, just so that you didn't have to type that in. The most common final answer, however, is our interval notation. Okay. Okay, thanks. The interval notation is where we typically, in the way we typically write our solutions. But my personal, and I didn't set this chart up, I copied it from something. What happens is when we solve these inequalities, we get set notation, we translate that into a graph, and then I usually translate the graph into the interval notation. So just know that one of these ways will be your final answer, okay? So just be careful with those. Don't stress too much about the notation itself. It's going to come, I promise. Couple of things I really need you to pay attention to on this is the difference between the round brackets, or the parentheses, and then what I call the square brackets. So notice that I'm going to use the same things on the graph that we use in the interval notation. That's why I like this chart, because you can always refer back to this chart, okay? So when I'm looking at this, let's say, for example, I like this one because it's a good example of using both things. This says A is less than X is less than or equal to B. So when I have the less than or the greater than, I'm going to be using the round brackets. But when an equals to comes into play, I'm going to be using the square bracket. And the square bracket simply means that I can use that number, that number, that endpoint is part of my solution set, okay? So just beware of the difference and pay very close attention to the types of inequalities. Keep in mind that this symbol and this symbol both point to the left, and they are our less than symbols. So less than, and then less than or equal to. And so if it points to the right, either with or without the equals to, this is our greater than. You do need to know those two. I know in elementary school they teach you about the crocodiles and the alligators, and I really never quite understood the crocodiles and the alligators thing, but you really do need to understand those two different symbols. So the other thing I like to tell students, and I usually do this in class, is I tell you to take your left hand, and your left hand actually makes an L. And then if you take your left hand and you kind of squish it down, it makes that less than symbol. So it's kind of cool. It really helps you remember these things, whatever works for you. But the less than will point to the left, and greater than points to the right. And we'll talk about how to translate those and use those. Okay. All right, so this is just a really good chart. If you don't print out anything else, if you're just really hard-headed, insistent, or don't have a printer or whatever, and insistent upon writing those notes, you really may want to save at least this slide onto your computer or print this page off or maybe handwrite this information. The final thing down here is that if we use everything, if our solution set is all real numbers, then we write that as negative to positive infinity. I do want to tell you one other thing about interval notation. Interval notation is always written where we have the smallest number on the right, the left-hand side, and the largest number on the right-hand side. So this is always written where I have small to large, always. So when I write an interval, it's always going to be the smallest number on the left and the largest number on the right. Doesn't matter what kind of brackets I have, parentheses, squares, it doesn't matter. If I have positive infinity, it's going to be on the right hand. If I have a negative infinity, it's going to be on the left side, because negative infinity is always the smallest number, positive infinity is always the largest number, okay? So just housekeeping kind of details on this. I'm not really sure, somebody popped out on us, so we'll check on that in a second. So, okay, so now let's work some problems with this. I know that's kind of intimidating. I always hate that slide, but I think it's so important that you have all of that information together. So, okay, all right. So, here we go, solving these inequalities. When we solve inequalities, we solve them just like we would solve equations. The only difference is that if I multiply or divide by a negative number, I flip the inequality around. That's the only difference in solving equations and inequalities, okay? And we'll talk about that as we get to these. Notice the directions on these. They solve the inequality, graph the solution set on the number line, and express your answer in set builder notation. So I'm going to show you how to go through that process. So we're going to solve it. We'll put that solution on a number line, and we'll talk about how to write that final answer and solution, okay? So we're going to start by simplifying before we solve. That's the same way we do everything. And so when we simplify, we're going to distribute this. And so this is going to give me 2y plus 2. Don't forget to take that 2 to the 1. And then plus 3, because it's hanging out here by itself, less than. And then I'm going to distribute my 5. So 5y minus 10. Don't forget to multiply that through there. And so now the next part of this is I'm going to simplify again because I have this 2 and this 3. So I have 2y plus 5 is less than 5y minus 10. Excuse me. And so now I get ready to solve this. The same thing I did before. I really want to do this where my y is on the left-hand side, just like I did with equations. I think it's easier to read everything. Sometimes it does give us some negatives, and we have to worry about that. But we can do this, and we're good. So you guys are beeping in and out on me, so I'm trying to figure out who's here and what's disappearing. Okay, all right. So in this case, I'm going to subtract 5y, and I'm going to subtract 5 from both sides. And I'm going to do this all at once. I'll write it down so we can actually see what's going on. So I'm subtracting 5y from both sides. And I'm also going to move this 5 over here to the right-hand side. So from my y terms, this is going to give me a negative 3y is less than. I'm subtracting, so I'm not changing anything. And then it's going to be less than negative 15 because I have these two negative values here. Now, like I said, multiply or divide by a negative, we flip the sign around. We add and subtract, we don't flip the sign around. It's only flipped and only turned around if you add or subtract. If you multiply or divide, okay? Not add or subtract. So here, to solve this, I have to divide both sides by negative 3. And this is when I'm going to turn my inequality around. So I divide both sides by negative. On this right-hand side, I'm going to get a positive 5. The left-hand side, I get a positive y. And now, rather than being less than, it's going to be greater than. So here is my solution. This is my inequality notation. So I'm going to put this on a graph. So my graph is going to look like this. I'm going to draw my number line, and I'm going to put 5 on my number line. I like to put 0 on my number line also. You don't have to. It just kind of gives me a reference point. When I get ready to shade this, though, I'm going to shade to the right because it says y is greater than. I want you to notice that I'm going to have a round parentheses because it says strictly greater than. There's no equals to on this. And so I'm going to have my round bracket here. And then I'm going to shade this to the right-hand side because it says greater than. And so this is what my graph looks like. I will tell you this, that these are going to be multiple choice. The graphs part will be multiple choice. You won't have to actually shade this on the number line on my labs. But the numbers you may have to write in. But for the graph part, you'll be able to pick a multiple choice. Some of you may have grown up with open and closed circles. Around parentheses is the same thing as an open circle. Works exactly the same way. Now, as far as the set builder notation, the set builder notation looks like this. It's X so that, that's what this vertical bar means, or X such that, X so that. So in other words, this is telling me my variable, and so that means that I can't use X because I'm kind of like not into it today. This would have to be a Y, would it not? Yes, because it says Y is. So this would be Y so that, and then Y is greater than 5. And really and truly, this is the part you're going to be typing in. Make sure you do make that variable consistent with what's there. Just be careful. Like I said, this is going to be given to you and you'll just type this part in. Okay. Questions on solving this or getting to the final answer? Any questions about this? That's a great time to ask. Pause and stop me. Okay. And okay. So let's see what other fun things we can do today. Okay. So again, we're solving the inequality. We're graphing the solution on a number line. Now this time it says express your answer in interval notation. Does that change the way we're going to solve it? Absolutely not. We're going to solve it exactly the same way. We're just going to write our final answer as that interval. So I'm going to do everything exactly the same. I'm just going to have a different final answer looking thing. So just pay attention to how they want you to write your final answer. Multiple choice, if it's multiple choice, they'll either all be written in set builder or they'll all be written in interval notation. So you're not going to have to pick that. But in the homework, you may have to, or the non-multiple choice questions, you may have to pay attention to that. So please do. So again, I've got this fraction here. We didn't like fractions the other day. Some of us didn't. Some of us like fractions. So what I'm going to do to solve this is I'm going to get rid of the fractions. So that means I'm going to multiply everything through by 3. So just like I did the other day, I'm actually going to write this down. So I have 3 times this. I'm multiplying by a positive. And so I have 3 times 3 and then minus, and I'm going to have 3 times n. So I'm literally multiplying it times each piece. And then I'm going to simplify it. So when I simplify this, the 3's divide out here. And so it's going to leave me with 4n minus 1 is less than 9 minus 3n. And so now I'm to the point I can solve this. So I've simplified it and I can solve it now. I'm going to solve it just like I did before. So here's where I'm going to see if anybody's paying attention to me. You can do this in the chat and you can either chat to me privately or you can chat to everybody. Somebody tell me what I'm going to move so all my n's are on the left-hand side. What am I going to do so all my n's are on the left-hand side? This is a pretty nice answer.
Add 3.
I'm going to add 3. Excellent. So I'm going to add 3n to both sides. And at the same time, what am I going to do to get all my numbers on the left-hand side? I mean, the right-hand side.
Add 1.
I'm going to add 1. Thank you. All right. So I'd just like to make sure every once in a while somebody is paying attention to me. All right. So on the left-hand side, I'm going to get 7n. And then less than, and I'm going to have 10 over here on the right-hand side. Notice again, doesn't matter. I'm not changing this sign. So now I need to divide both sides by positive 7. So I'm not turning my inequality around. It's a positive. N is less than 10 sevenths. Okay, so you may not like the fraction, but it's okay. 10 sevenths is not a bad number. So I'm going to go from my inequality notation to my number line, all right? So I'm going to draw my number line again. On my number line, I'm going to put 10/7. Now, does it matter where 10/7 is? No, it's a positive value. It falls between 1 and 2. If you want to put some other numbers on there, if you want to put 0 on here, that's fine. If you want to put 1 on here, that's great. If you want to put 2 on here, that's fabulous. 10/7 has to be on the number line because that's kind of my reference point here. So now I'm going to look at this and I'm going to say, okay, it says n is less than 10/7. So which direction am I going to shade? Left or right? Left, exactly. And am I going to have a round or a square bracket with that left shaded?
Round.
Round, exactly. So it's going to be round, and then it's going to be pointing to the left, and then we're going to shade to the left. And so this is what my graph looks like, okay? So it said to graph. I like to graph before I ever look at that interval because I think the graph helps you get your interval. So if you go back to that chart and look back in that chart, if you had an interval that looked, or a graph that looked like this, and intervals always go smallest to largest, my smallest number here is negative infinity because my arrow keeps going. So it's negative infinity to 10/7, and then I have a round bracket. I always put a round bracket on the infinities, either positive or negative. Doesn't even matter what the other end looks like. If negative or positive infinity is involved, it's always a round bracket. Questions?
Yes, I have a question. Why didn't we flip the sign?
Great question. So I'm only going to flip the sign if I multiply or divide by a negative number, okay? So you flip inequality. Sorry, I can't spell this one in. If you multiply or divide by a negative, okay? So in the last one, let me finish writing this so I can multiply or divide by a negative. So in this one, I divided both sides by +7, so my inequality didn't turn around. Go backwards one slide, and on the first one, I divided both sides by -3, and that's what turned my inequality around. Does that make sense?
Yes, ma'am.
Perfect. Excellent. Okay. That's huge. So we planned that out very nicely for you to ask that question at that perfect time because that's really, really kind of a big deal. Any other questions? Okay. All right. So these next problems are what we call compound inequalities. And the reason we call them, excuse me, compound inequalities is because I have multiple statements somehow, some way. Sorry about that. So in this problem number 3, I have one big long inequality, but it has two inequality symbols. In number 4, I have two separate statements connected with this conjunction, which we'll talk about what that means in a second. So I'm going to solve them the same way, except that in this 3-piece one, I have to do 3 things. So whatever I do to the center, I have to do to the ends. Because when I have 3 parts, my x is generally in the middle, and so that's where I want to get x by itself. So in this case, because the 5 is subtracted, I'm going to add 5 to all 3 parts. So I'm going to add 5 in the center to get that x by itself, and that means I have to add 5 to the left-hand side and to the right-hand side. So on the left-hand side, I have a 3, and this is less than or equal to 2x is less than or equal to 7, right? So now I'm getting closer to having that x in the center. If I had just had this part, the 2x is less than 7, I would divide both sides by 2. Going to do exactly the same thing, even though I have all 3 parts. Notice that it is a positive 2, so I'm not going to do anything to my inequality statements. I'm going to leave them the same. So on this far end, this left end, I have 3/2 is less than or equal to x is less than or equal to 7/2. Now, this should kind of make sense because I have these little less thans. Everything's pointing to the left, and my smallest number is on the left side. So 3/2 is smaller than 7/2. The directions say to express each solution in interval notation. Notice there's no graph part here. Does that mean I don't need to do the graph? I don't know. I like the graph, and it doesn't hurt you to draw the graph. Some of you guys are getting really good at this or will be very good at this, and you'll be able to say, I can go straight from the inequality to the interval. That's fine. If you don't need the graph along the way, that's okay. I'm going to draw the graph because I think it helps us to see what's happening here. So I'm going to sketch the graph here. So here is my number line. And on my number line, I'm going to put those numbers 3/2. That should be a 3. 3/2 and 7/2. Notice, because my number line goes in order, 3/2 is smaller than 7/2. Now, when I get ready to graph these, a couple of things I want you to notice about this. I can read this a couple of different ways. I like to read this as x falls between 3/2 and 7/2 because literally to me that's exactly where it is. Okay. You can also read this as x is less than 7/2, and if I read from x is greater than 3/2, or 3/2 is less than x. Okay. So if 3/2 is less than or equal to x, and x is less than or equal to 7/2, I'm going to use square brackets on here, and I'm going to shade in between. So here we go, and we're going to shade this piece in between here. All right. Should have picked something other than green, but that's okay. All right. So now I have my shaded part of my number line. And this allows me very nicely, I think, to translate this into an interval where I write my smallest number first with the square bracket to my largest number with the square brackets, because I have the equals to on both of these. You can go straight from this statement to this statement. Either way is okay. Right? On number 4, you're going to see, I hope, where the graph is very helpful to us because I have a different kind of compound inequality. Questions about any part of this on number 3? Okay, all right. So let's look at number 4. It is again a compound inequality, but I have a connector word here. And is a very special connector word. What it means is that both of these things have to happen at the same time. So I'm going to solve my two inequalities separately, and then we're going to graph it to find the solution. So you don't have to have the graph for a compound inequality like this just because of the nature of the solution. But for a compound statement like this, you really need to graph it. Okay, so we're going to start with the first one. And the first one here is my 2x minus 3 is less than or equal to 5. So I'm going to start by adding 3 to both sides. And this is going to give me 2x is less than or equal to 8. If I divide both sides by positive 2, I'm going to get x is less than or equal to 4. And that's really nice. And I'm going to scroll the screen down here because I want to graph this. So I'm going to actually go ahead and graph this to begin with. So here's my number line, and here is 4 on my number line. And it says less than or equal to 4. That means I'm going to need a square bracket, and I'm going to shade to the left. And so my square bracket here and shaded to the left. So this is my x is less than or equal to 4, right? So far, so good, hopefully. So then I'm going to move into the second part of this problem. I'm going to subtract 1 from both sides. I'm subtracting, but I don't turn my inequality around because that's a subtraction, not a division or multiplication. So I have 5x is greater than positive 5. Dividing both sides by positive 5, I end up with x is greater than 1. Okay. So the next thing I'm going to put on my number line is 1, and 1 is over here to the left of 4, so I need to put it in order on my number line. It says greater than, notice it's pointing to the right, that helps me out. Less than is pointing to the left. I am going to have a round bracket though because of the greater than without the equal to on here. So I'm going to have a round bracket and I'm going to shade to the right. Now, here's what I need you to see. And is what we call overlap. Both things have to happen. So where both pieces are shaded is between 1 and 4. And so if I were to show, oh, that's terrible. Let's go orange. If I were to, that's not a whole lot better. That's because I didn't get orange. Okay, sorry. Here, we're trying to get this lovely color here. Aha, yeah, go ahead. Okay, there we go. All right, here we go. So we can see that this is the part of the number line, which is actually my solution. So this is the only part that's my solution. And so when I translate this into an interval, this is what it's going to look like. Round bracket 1 to 4 with a square bracket. And this is my final solution. Put several things together there. Questions?
So on the test, are these problems gonna be on there too?
Yes. On this first test, yes. We're going all the way through this material. You mean with the and in there?
Yes, ma'am.
Yes. So I need you, well, it's possibly on the test. I don't know for sure. I don't remember what's exactly, but it's possible. Okay. So the and is the overlap. We're going to look at the or word in just a minute, but and is overlap. So you have two different connectors in intervals, or no, excuse me, in inequalities. You have an and connector and you have an or connector, but and is the overlap. So I do need you to pay really close attention to those. All right. So here we go with our OR connector. So again, we're solving a compound inequality. We want our final answer as an interval. So my connector word now is or. Or means either one or both, okay? So typically my and inequality solution is a single solution. Typically, or is multiple solutions, not always, but most of the time. And of course, I'll probably prove myself wrong on this question, but we'll get it together, okay? So again, I'm going to do this one just like I did number 4. I'm going to solve two separate inequalities, and I'm going to graph them to figure out what my final solution is. So my first inequality is 3x plus 1 is greater than 7. So I'm going to be subtracting 1 from both sides. This is going to give me 3x is greater than 6. Dividing both sides by positive 3, I get x is greater than 2, right? So if I put this on my number line, so here's my number line, and on my number line, I'm going to put the value of 2, and it says x is greater than that number, so it's going to be shaded to the direction it's pointing to the right. It's going to be an open circle, an open parentheses, because there's no equal to under here. So I'm going to have a round bracket, and I'm shading to the right, okay? So let's solve the second inequality. Good. Please make sure that you're letting me know if you have a question. I'm going to look real quick at this, make sure nobody's raising their hands at me and I'm not seeing them. Okay, I'm not really good at the hand raising thing, so just like beep at me and say, I have a question. So on this one's, we got to be really careful here because I have a minus 4x. So I'm going to start by subtracting 3 from both sides. And this is going to give me negative 4x is less than positive 12. Dividing both sides by negative 4. Notice what's going to happen. I have x is now greater than negative 3. Okay. My inequality flipped around. Pay really close attention to that because of the fact I divided by that negative. Okay. So I'm going to put negative 3 on my number line. -3 is over here to the left of +2. It's greater than, so it's going to shade to the right with a round bracket, okay? Because there's no equals to under here. So let's do this. Round bracket on 3, shaded to the right. Now, here's where we have to pay attention to this or word. Or means either one or both, okay? Because this is an or inequality, then my solution has to include everything that's shaded. And I want to write that as simple as possible. So my solution interval is going to be -3 to +infinity, okay? I want you to think about something really quickly over here. I'm going to make a side note, okay? If this problem had been 3x plus 1 greater than 7, and notice the different connector word here, 3 minus 4x is less than 15, my solution would have been 2 to +infinity, okay? And the reason for that is that and is the overlap, and the overlap is 2 and larger. Or is all inclusive, okay? It means I have to include everything that's shaded, but I don't need to repeat myself. Sometimes the or is two ends of the number line, and so I have two inequalities, and sometimes the or is a whole bunch of things that are shaded together. And is the overlap. Does that make sense? That's I know it's two different problems, basically the same problem, and the only difference is the connector word. Let me know if you've got questions. Okay, all right. So we're going to actually take this and we're going to talk about absolute value equations and inequalities. The equations are pretty nice, and then the inequalities, we're going to pull back on that information we just got through talking about with the ands and the ors, and so that's why it was really important that we did that first. Okay, so our absolute value equations are I think they're super nice, so that you solve them basically one way. Okay. Typically with the absolute value equations, you're going to get one of three types of solutions. Sometimes you get no solution. I'm going to tell you what no solution looks like. If I have an absolute value equal to a negative number, that can never happen. And that's going to translate into no solution or the empty set. Okay, empty set means no solution. Absolute value has to be either equal to 0 or greater than 0. Absolute value can never be negative, okay? Absolute value by definition is the distance that a number is from 0. So I can take the absolute value of a negative, or I can take the absolute value of a positive, and it's always going to produce for me a positive number. So with that in mind, okay, if I have the absolute value of x is equal to 0, I'm going to get one solution. But if I have the absolute value of x is equal to a positive number, then this is going to give me two equations to solve. I'm going to solve the equation where x is equal to the number itself, or x is equal to the opposite of that number. And I'm going to solve two equations. So if I have the absolute value of x is equal to a positive number, then I'm going to solve two equations. So I solve two equations here. Notice on all three of these scenarios, it's absolute value on one side equal to something. Okay, that's going to be really important in just a second. Okay, all right, so here we go. We're going to start with number 1 here. That's always a good place to start. And I have absolute value of x minus 1 is equal to 7. So that's not negative, that's not 0, that's a positive. So that means that I'm going to write 2 equations. I'm going to write x minus 1 is equal to 7, and then I'm going to write x minus 1 is equal to the opposite of 7, which is negative 7. Okay? So now I have 2 equations to solve. Okay? That means I'm going to get 2 solutions. So I solve this one by adding 1 to both sides. I get x is equal to 8. That's my first solution. That's one solution. I add 1 to both sides here, and I get x is equal to negative 6. That's my second solution. 2 solutions. That's it. I'm done. Questions? That was pretty nice, yes? We like that one?
So why did you like with the absolute value sign? Like I don't understand why you, because normally I thought you got just rid of the one. Or
I think I understand your question. So let me ask you a little bit nicer question. So let's come over here to the side and let's say if I ask you what number, the absolute value of what number was equal to, let's say 8, okay? What could x be equal to? What number could I take the absolute value of and get 8? That's not supposed to be a hard question. The absolute value of what number gives me positive 8?
8.
Exactly. That was it. That's all I wanted you to tell me. Now, is there another number that could be inside this absolute value that when I take the absolute value of that number, it gives me 8?
Negative 8.
Yes. Okay. And so that means there are actually 2 numbers that are 8 units from 0. One of those numbers on the number line is positive 8, and one of them is negative 8. Okay? So the absolute value is the distance that a number is from 0, and so it either could have a positive value or a negative value. Now, the difference in this problem and the one we solved is I have something other than just an x in here. So my whole quantity, x minus 1, is 7 units from 0, okay? And so it could either be 7 units to the left from 0 or 7 units to the right of 0. And so to the left of 0 would be this negative 7, which means my value of x is actually sitting at negative 6. 7 units to the right means that my value of x is actually sitting at positive 8. Does that make a little bit more sense?
Yes, ma'am.
Okay, so it kind of the short version is that what's inside the absolute value could either be positive or negative, and I had to take both of those into account. Okay. All right. So on number 2, though, I've got to do something else first. Okay. Once again, I'm pointing out to you that all 3 of these little scenarios that I gave you have absolute value on the left side, equals, and then a number over here on the right-hand side. That is not what I have in number 2. I have the absolute value of 6x plus 7 minus 8 is equal to 3. So before I do anything else to try to solve this, I have to get the absolute value by itself. So before I go getting rid of the absolute value, before I go trying to solve this with 2 equations, I have to move the 8. So very first step on this problem, and you cannot skip this step, so put a big star here, is I have to add 8 to both sides of my equation, okay? And when I do that, I get the absolute value of 6x plus 7 is equal to 11. But you have to do this step first. I don't know how to emphasize that anymore other than by putting a million stars here and saying it one more time. You have to get the absolute value by itself. All right. So now, in keeping with what we did in the previous problem, I'm going to solve two equations. And so I'm going to take what's inside that absolute value. I'm going to take my 6x plus 7, and I'm going to set that equal to positive 11. And then I'm going to take 6x plus 7, and I'm going to set it equal to negative 11. And the whole concept revolves around the fact that what that quantity is inside my absolute value could be positive, produce a positive 11. It could be negative and still produce a positive 11. Okay? And so now I'm going to solve each of these separately. So I'm going to subtract 7 from both sides. That's going to give me 6x is equal to 4. Dividing both sides by 6, I get x is equal to 4/6, but I can simplify 4/6, and 4/6 simplifies to 2/3. So I have x is equal to 2/3 is one solution. The second part, again, I'm going to subtract 7 from both sides. Gives me a very different looking number over here. I get negative 18. Dividing both sides by 6, I get x is equal to negative 3. And so these are my two very different looking solutions, but they are both solutions to this equation. Questions? All right. Let's look at number 3 here. So I'm going to backtrack for just a second, back over here to where I had this page. Remember that, I'm going to go back and forth. Yeah, this is probably driving y'all crazy. This one is equal to 0, all right? So I'm only going to have one solution here, okay? So if the absolute value of something, x is equal to 0, I only have one solution. What is that solution? Well, I take 7x plus 3, and I set it equal to 0. The other thing you can remember is you can think about this as two solutions, but there's no difference between positive 0 and negative 0, right? So you're only going to get one solution. All right. So I'm going to subtract 3 from both sides, and I get 7x is equal to negative 3. I'm going to divide both sides by 7, and I get x is equal to negative 3/7. That's my solution. That's the only solution I have. There's only one number I can use and make that equal to 0. Can anybody tell me what the solution to number 4 is?
No solution.
Exactly. Absolute value is always positive. And so if I have the absolute value equal to a negative number, my answer is that there is no solution. The other way to write no solution is to use this little circle with a line through it, which means the empty set. These are my favorite problems. Now, these are sometimes this will be like a pull down menu, or it might be multiple choice. Some of these absolute values will give you like it's what I call quasi multiple choice. One of the possibilities would be the solution is, and then you would type in, say, like x is equal to these two numbers. And then another choice would be no solution. Okay, so in this case, you would select no solution. All right. So now we're going to talk about the inequalities. So the absolute value inequalities, we have two different types of absolute value inequalities. We're going to do the less thans first. The less than inequalities, absolute value inequalities, work like the and inequalities. Okay, so less than is like an and statement, except I'm going to solve every one of these like not every one of these. I'm going to solve the less than absolute value problems like we did the first compound inequality, where we had a long string of things. And so here's what I'm going to tell you. This is kind of my aside note over here. If I have the absolute value of x is less than a constant, then I'm going to write this as, I'm going to drop the absolute values and I'm going to put negative constant is less than, x is less than the positive constant. If there's an equals to in here, if I have the absolute value of x is less than or equal to a constant, these are positive numbers, then the only difference is that I'm going to have a less than or equal to here on either side, okay? This is my personal, it does require you to pay attention to the fact that I have a less than, which means that I'm going to end up with a string inequality to solve. I'm going to end up with a three-parter, okay? But it will always work this way, and it will keep you out of so much trouble, okay? So be careful, all right? So in this particular problem now, I have the absolute value of not just x, but x minus 2 is less than 3. So here's what my inequality is going to look like. I'm going to have negative 3 is less than x minus 2 is less than positive 3. That's my inequality we're going to solve. We've already done these, okay? And that's why it's so important to do those first. So now to solve this inequality, I'm going to add 2 to everything. So I'm going to add 2 to this end, to the middle, and to this end. And so this is going to give me negative 1 is less than positive x is less than positive 5. Okay. So the problem says express our answer in interval notation. We can translate this into a number line first. There's nothing wrong with that. Or you can go straight to your interval notation. I'm going to go straight to the interval notation, but if anybody wants me to throw that number line in there, just tell me that or send me a message that says, hey, number line, please. And I'll definitely go back and do that. So it's super easy to do. I think y'all are kind of getting the hang of it, but if you want to see it, just let me know that. So my interval notation, and that's what I love about these guys, is literally I'm going to have a round bracket. It always goes smallest to largest. And so round bracket 1 to round bracket 5. Notice x falls between these two numbers, and that's what that interval says. It looks suspiciously like an ordered pair, so be really careful with it. Questions? Questions. All right, number 6. It says, notice it says pay close attention to the inequality symbols. Okay. Number 6 says the absolute value of 3x minus 7 is less than or equal to 0. Can the absolute value be less than 0? Somebody needs to answer me. Can absolute value be less than 0?
No.
No, it can't. Does that mean that this inequality has no solution? The answer is no, it does not mean that. So let me show you the difference here, and here's where I wanted you to pay close attention. If the problem said the absolute value of 3x minus 7 is less than 0, I would have no solution. This symbol is different than this symbol. So what this means is that, yes, there are no values which make this less than 0, but there is one value which makes this statement true. And that is when the absolute value of 3x minus 7 is equal to 0. So because of the less than, I have no solution for that part, but I do have to solve still the absolute value of 3x minus 7 is equal to 0. And that's part of why we had that problem a while ago, so I could cheat and go back and think about this one. And I get that x is equal to 7/3. Okay. So my only solution is just this point. You may, because it says to answer in interval notation, it may give you this set bracket notation and say that you have to say it's just this one number, and that's what this notation means, okay? So there's no interval for this solution because there are no values that make this whole thing less than 0. There's just one value that makes it equal to 0. That's a little bit of a challenging question, so that's why I wanted to make sure that I touched base on that one. So questions? Just pay attention to the inequalities. All right. So now we're going to move into greater than. Notice on the last one, they were all less than. This one, they're going to be greater than. So as you might expect, I have another way to solve these. Greater than, absolute value greater than is going to act like our or statement, okay? So I'm going to solve it. I'm going to make a little note over here. I'm going to write this down. If I have the absolute value of x is greater than some positive constant, I'm going to solve two inequalities. I'm going to start with x is less than the opposite of the constant, or, and it's always going to be an or, x is greater than the constant, okay? So notice I rewrote this as two separate inequalities. I can do the same thing if it's a greater than or equal to a positive number. I would have x is less than or equal to this opposite, or I would have x is greater than, oops, that should be equal to here, greater than or equal to my positive constant. Here's what I need you to pay attention to. When I changed this sign, I changed this sign. It's kind of like I multiplied or divided by a negative. Think of it like that, okay? So I have the two ends of my number line. So for less than, I'm sandwiched between two numbers. For my greater than, I have the two opposite ends. And so it's going to be this or statement where I have both ends of my spectrum. And I'm going to put these probably on a number line before we actually write the interval, just because I think it's helpful to you. All right, so let's see if we can translate this information into this problem. So absolute value of x plus 4 is greater than 5. I found that doing the less than negative part first helps a little bit. It really doesn't matter which one I put first or second, but I found over the years that putting the less than the negative one just makes for fewer confusion places. I think that's right. Okay, anyway, so I'm going to take x plus 4, and I'm going to say this is less than negative 5, or, and I'll do this in a separate color, x plus 4 is greater than positive 5. Solving each of these separately, I'm subtracting 4 from both sides, so I have x is less than negative 9. If I were to put this on my number line, so here is my negative 9, and it's going to be a round bracket, and it's going to be shaded to the left. Kind of cruddy shading there, but we get the idea, okay? For the second part of this, I'm going to subtract 4 from both sides also, but now I have x is greater than positive 1. Here is 1 on my number line. Greater than means I shade to the right, round bracket, and so it's going to look like this. And so if I do it in this order, it typically, most of the time, it puts the smaller one on the left side and the larger one on the right side. And I just think that helps you guys. And so now as I translate this into my solution set, here's where we're going to do something a little bit different. So I have negative infinity to negative 9 union, and then 1 to positive infinity. This union symbol is going to be on the template. So when you get ready to type in your answers, that's going to be the little template symbols template will pop up, and union is one of those options. For multiple choice, it will probably be really mean, and one of the solutions will be negative 9 to 1, because if you're not paying attention, that's what you get. But one of the solutions would actually be this statement with the union symbol in between it. Questions. This is a biggie. Okay. So somebody look at number 8 and tell me what the first thing I need to do is. I have to do
Add
something.
5 to both sides.
Oh, yes, add 5 to both sides. Oh, goodness, I don't even know why I'm doing this. Y'all are so good. Okay, so I'm going to add 5 to both sides. Okay, that's going to give me, notice I'm not going to do anything with my absolute value. Absolute value of 7x minus 1 is greater than or equal to 13. Greater than means I have two inequalities. It's going to be my or statement. Absolute value greater than is always going to be my or statement. And so I'm going to move them over here so we can kind of see and don't run out of space too badly. So I'm going to have 7x minus 1 is, we're going to do the less than one first, is less than or equal to negative 13. And then my second inequality is going to be 7x minus 1 is greater than or equal to positive 13. And I'm going to solve each of my inequalities. Add 1 to both sides. That gives me 7x is less than or equal to negative 12. Not necessarily a lovely number, but it's okay. Less than or equal to negative 12 sevenths. Putting this on my number line. Negative 12 sevenths. Somewhere on this end. Less than or equal to means that I'm going to have my square bracket and I'm going to shade to the left. Adding 1 to both sides on the second one, I have 7x is greater than or equal to 14. I'm going to divide both sides by 7. I have x is greater than or equal to 2. So 2 is over here to the right of negative 12 sevenths because it's a positive number. And it says greater than or equal to, so it's going to have a square bracket and it's going to be shaded to the right because it says greater than. And so it's going to look like this. Again, I have two separate inequalities. And so my solution set is going to look like this. It's going to be negative infinity to negative 12 sevenths. I'm going to use my square bracket. Notice no square bracket on the infinities. Union square bracket 2 to positive infinity. Questions? Questions.
So is the reason that you flip the sign because it's or and it can be both of them? Or
Yes. Because I flipped that sign and made that a negative is because I have because the greater than says I have or and I have both ends of the number line.
okay.
Good question. Greater than, I always like to think of it as the greater than, the absolute value greater than or equal to, it means I have more solutions. So that's why I have those two inequalities to solve. Less than means I have fewer, I just have one to solve. Some of you may have learned to solve these where with the less than you did an and in the middle with two statements. That's okay, there's nothing wrong with that. I just think it makes it a little bit simpler if with the less than you just solve the one inequality. If you learn to do it with the less than and the and instead of the or, just make sure you graph to find your solution, okay? And that's kind of one of those things, if you're like, I know I learned to do this with the and, but I'm just kind of missing something on it, drop me an email, we'll jump on a WebEx session and I can show you real simply how to do it with the and. I just don't like to show multiple ways of something like that during class time because I think it's confusing. All right. So last one of these inequalities, absolute value inequalities. Again, we're paying very close attention here. This says the absolute value of x plus 7 is greater than 0. Greater than 0 is positive numbers. When is the absolute value greater than 0? It's not a trick question.
When it's positive.
Yeah, and when is the absolute value positive?
Always.
Yeah, it's always positive. See how it doesn't try to be mean? Okay, except that this says greater than and not equal to. So again, we're going to look at a little bit different problem. If this had said the absolute value of x plus 7 is greater than or equal to 0, this solution would have been all real numbers, negative infinity to positive infinity, all real numbers, because every number would have made the absolute value either positive or equal to 0. The problem here is that this just simply says greater than 0, okay? And so what happens here is that I actually still solve the two inequalities, and it's going to look a little strange. This one says x plus 7 is less than, well, negative 0 is still 0. And the other inequality I'm going to solve is that x plus 7 is greater than 0, okay? So x plus 7 is greater than 0. So I'm still going to solve both inequalities. And if it had said equal to, I would be done. I would say all real numbers, I'm done. But because it says strictly greater than, I do have to solve these two inequalities. This one says now x is going to be less than negative 7. This part says x is going to be greater than negative 7. And you might be going, is that not the same thing? Yeah, well, it's really close. So I'm going to show you what happens when I graph this, because I think that's kind of a big deal here. So I'm going to put negative 7 on my number line. Obviously, that's what's happening here. This one is everything less than, but what kind of bracket do I need on both of these intervals? Round or square?
Well,
Round. And so it's really everything from here to the left. And then it's going to be everything from here to the right. But what happens is that I actually have this space in here, which is an open circle. And so my solution interval looks like this: negative infinity to negative 7, union negative 7 to positive infinity, because I don't actually use that negative 7. And that's basically what happens is I'm pulling out that one value that makes this absolute value equal to 0. So I think this is a little bit easier way to solve it than some other ways. So, but just notice that if this had an equal to under here, I basically my number line would have overlapped everywhere. So I would have had those square brackets. Okay. Questions? I think that may be one of the hardest ones to do. Okay. So I have one more type of inequality to show you how to solve. This is just the chapter that keeps on giving. We are actually not going to do the rational inequalities in summer school. We usually do rational inequalities in the fall semester, but we usually skip them in summer school. I don't really know what that says about them other than they're important and they're really nice, but they're not essential to your well-being. And sometimes I have to cut a few things out in summer school. And so don't tell the people who take this in the fall semester and the spring semester that there's anything that's not important. Tell them we cover absolutely everything in summer school, okay? Because otherwise they'll be mad. So it's our secret. Please don't tell. All right. So let's talk about what I call polynomial inequalities. All right. So that's really what we're going to be doing. I know there's a bunch of words on this page. and we are going to get through them together. What I need you to realize is that this is a step process, and I am going to walk you through every single solitary step. But I like for you to have this to refer back to when you're working on your homework or taking your quiz. So for every one of these problems that we're about to see, we're going to take the problem, we're going to set it equal to 0, we're going to solve for x, we're going to find values of x, and we're going to call these values boundary points. Boundary points we're going to put on a number line, we're going to pick test values, we're going to test our test values to see whether or not we get a positive or negative. What do we want it to be? Well, that's going to depend upon the problem. And then we're going to write our final answer in interval notation, okay? So we're going to go through these steps piece by piece, but this is just really for you to refer back to, okay? So let's start with problem number 1. We're only doing 3 of these, so it's really not going to be that bad, I promise you, okay? And I am going to add one other step in there that I think is really important. Okay? So these are going to say solve the polynomial inequality, express your solution as an interval, and it's going to look something like this. I've already drawn the number line on here because I wanted to kind of make sure that you knew it was really important and makes it a little bit easier for me to work through the problem. So the very first thing I want to do is to point out to you what this inequality says. It says I want to solve the problem x minus 1 times x plus 3. I need that product to be greater than or equal to 0. So what I want you to do right now is I want you to write on your paper, does greater than or equal to 0 mean positive or does it mean negative? You don't have to tell me, I just want you to write it. Greater than or equal to 0, is that going to be positive or negative? Okay, so now I'm going to tell you, I hope you wrote down positive. So I always want to look at this inequality in relationship to 0. I need it to be in relationship to 0. If it's not, we've got to do some other work. This inequality is telling me that as my end result, I want to have a positive product. Okay. So a positive product is what I need. All right, that's huge. Okay, that wasn't on the other page. I need to add that to my information because I think this is huge. So now we're going to go through the process. The first step we're going to go through is we're going to find what I call my boundary points. And my boundary points I'm going to abbreviate because I get tired of writing that word out. My boundary points I'm going to abbreviate. And I'm going to find my boundary points by taking this x minus 1 times x plus 3 and setting it equal to 0. I don't care whether this is positive or negative. I don't care whether there's an equals to or not an equals to under here. I'm going to find my boundary points by setting this equal to 0. That means, because we already know how to solve quadratic equations, that means I'm going to take each of my factors, I'm going to set it equal to 0, and I'm going to solve for x. And so my x values are positive 1 and negative 3. These are my boundary points, okay? 2 boundary points. I am going to put my boundary points on my number line. So that is the next part of this. So here are my boundary points on my number line. Okay. Next thing I'm going to do, and this is not actually listed as a step, but it's just something personally I like to do. I like for you to write, because I write what I call my possible solution intervals. Okay, and I'm going to tell you why. So I'm going to make a list of possible solution intervals. Now, we're going to do this based on how I broke up my number line. If you notice, by putting 2 boundary points on it, I've divided my number line into 3 pieces. My first part of my number line goes negative infinity to negative 3. Negative infinity to negative 3. I put a round bracket there. I don't want a round bracket. Why don't I want a round bracket? Can anybody tell me why I don't want to put a round bracket here? so make you answer this in class?
Because 3 of
It's got to do with something we've already got written on the page. When did we use square brackets?
for greater than or less. I mean, for equal to or the.
That's it, for the equal to part. Didn't matter whether it was greater than or equal to or less than or equal to, okay? We use square brackets when we have this equal to part under here. So I'm gonna go ahead and put square brackets on here. That means I can do square bracket -3 to square bracket 1, because that's the next part of my number line, and then square bracket 1 to positive infinity. Now, here's the other thing I need you to pay attention to, and that is, where did I get these intervals? Okay, and where I got these intervals was literally from this number line. So we took the number line and translated it into intervals before. I know nothing's shaded here, and that's okay. But this part of my number line is represented by negative infinity to -3. This part of my number line right here is represented by -3 to 1. And then this part of my number line is represented by 1 to infinity. And just like I think it was Justin, I could be wrong, that said, because of the equals to on there, I'm going to put a square bracket, okay? If my original inequality symbol had not had the equal to under here, I would put round brackets on everything. Now, the reason I do the possible solution intervals is twofold. One, I think it kind of helps you be organized. We're going to put a bunch of stuff on this problem. Two, if you get to the end and you can't figure out how to write your solutions, I guarantee you your solution's going to be listed up here. Somehow, some way, your solution is going to be listed up here. So if it's multiple choice and you see numbers that don't look like this, they're not going to be part of the solution, okay? If you're typing in the answer, you know that 1 or 2 or 3 of these, this is what your solution is going to look like, okay? So I just think it helps you to be organized. So I found my boundary points. I put my boundary points on the number line. Now I need to, and I found my possible solution intervals. The next thing I need to do is to come up with what I call test points, okay? Your test points are actually, so this was step 2, and so this is going to be step 3. We're going to find our test points, and we're going to check those test points, okay? I need a test point in each interval. I need a number that's less than -3. I like -4. I need a number that's between -3 and 1. I like 0. You can pick any number you want to in here. And then I need a number which is greater than 1. I'm going to pick +3. You could pick 2. You could pick 5. You could pick 351 if that's your favorite number. Okay, it doesn't matter what number you pick as long as you pick one in each interval. All right. So my test points are going to be x is equal to -4. X is equal to 0, and X is equal to +3. And what am I going to do with these test points? Well, my original problem said I wanted a positive product. So I'm going to test my points in this product, and I'm going to see what I get, right? So I'm going to take -4 and subtract 1 and -4 plus 3. This is going to give me -5 times -1. And -5 times -1 is +5. Stop right now. Is +5 a positive product? The answer is yes, it is. So this, and you can even put a little positive sign here. This part of my number line is going to be part of my solution. If you want to shade it, that's great. Let's shade it. Let's say we're going to use everything in here, okay? Because it gave me a positive number, right? The next test point is 0, so I'm going to plug 0 in here. 0 minus 1, 0 plus 3. This is going to be -1 times positive 3. This is a negative 3. Negative is not a positive number, okay? I did not get a positive product when I plugged in 0. So I can put a little negative sign here, but I'm going to put a big fat no here. I am not going to use this one. In fact, you can put an X through this interval if you want to. Does that mean the next one automatically works? Sometimes yes, sometimes no. I wouldn't count on it. I would check it, okay? So then the last one here, 3 minus 1, because I'm putting my test point in here, 3 plus 3. This is going to be positive 2 times positive 6. It gives me positive 12. That is a positive product I got out of this. So I can put a little plus sign here. I can write the word yes here. I can shade this if I want to. All right, whatever it takes to help you realize that this is part of my solution. So that means that my final solution here has two pieces. It is negative infinity to negative 3, square bracket, union, that little palette will be available to you, 1 to positive infinity. Oh, I'm going to take a breath and let you ask me questions if you have them. A lot to absorb on here. Okay. So we're going to move to the next one. We're going to work it exactly the same way. The only difference is I want you to notice that I had 2 factors here. I'm going to have 3 factors in the next one, and we're going to see what that changes. Not a lot, but it does change something. The other thing that I want to point out to you is now I still have a 0 over here, but I have a less than. And so less than 0 tells me I have a negative product, okay? So this means that I need, that I need a negative product, okay? Less than 0 tells me negative. Some things around my accident. All right, so step number 1, we need to find those boundary points. So we're going to find the boundary points by taking x minus 1 times x plus 4 times x minus 3 and setting it equal to 0. You might be wondering, but it's not equal to 0. I know that, but your boundary points are where it's going to be equal to 0. And we'll just be careful when we write our intervals, and we won't include those numbers, which means we'll have to use round brackets. Yes, you got it. Okay, so I'm going to take each of my factors and set them equal to 0 and solve for x. Now, one thing I do want to point out to you is now I'm going to have 3 boundary points. So I'm going to have 1, negative 4, and positive 3. When I put these on the number line, I want to make sure I put them in order. So negative 4 comes first because it's the smaller one. Then I have positive 1, and then I have positive 3. Okay, so they go smallest to largest on my number line. My possible solution intervals on the last problem, 2 numbers, 3 possible solutions, okay? 3 numbers, 4 possible solutions. So my possible solution intervals, negative infinity to negative 4, I gave it away, round bracket. Negative 4 to positive 1, round bracket. 1 to 3, round bracket. And then 3 to infinity, everything has a round bracket, okay? And the round bracket, because it is strictly less than. Doesn't matter that it's less than as opposed to greater than. It's got to do with the fact there's no equal to part on there. Okay. All right. So now I need to pick a test point. And I would suggest that while I'm writing the word test point over here, or you're writing the word test points, I want you to go ahead and pick some test points. You should have 4, 1 in each interval. And then I'm going to go back and make sure that yours are in the same place mine are. You don't have to pick the same numbers. You can pick different numbers. Okay. I'm going to pick -5. I'm going to pick, 0. I like 0. 0 is a lovely number. I'm going to pick 2. And I think I'll pick +5. One thing I didn't point out to you on the last problem that I'm going to point out to you here, notice that I circle my test points. You have a bunch of stuff on here. I just do that personally because it helps me to distinguish them between my boundary points. And I don't know, these are the problems where there's so much stuff on the page that it's so easy to get confused and lost. And so I usually do circle those test points just so that I know there's a difference. Okay. I am going to have 4 of them this time, so I'm going to test -5. I'm going to test 0. I'm going to test 2, and I'm going to test +5. Where am I going to test them? I'm going to test them in this very long 3-term product of x minus 1, x plus 4, and x minus 3. Reminding you again that I want negatives, okay? That's what the less than 0 tells me, is I want my answers down here when I test these to be negative. That means it's going to be, that interval is going to be part of my solution. So let's plug in -5. So I have -5 minus 1. I have -5 plus 4. And I have -5 minus 3. And so this is going to give me -6 times -1 times -8. A negative and a negative and a negative is going to give me negative, and 6 times 1 times 8 is 48. Right? So I can put a negative here, and I'm going to say, hey, that's what I want. And so I'm going to actually go ahead and shade this. And so I know I want this part. I'm going to put a big yes here and say, yes, I want to use this part of my number line. Okay. So now we're going to check 0. And I'm going to have 0 minus 1, 0 plus 4, 0 minus 3, -1 times 4 times -3 is going to give me a positive 12. Okay? Negative and negative is positive. 4 times 3 times 1 is 12. This is going to be positive. But I wanted a negative product. So that means this is not part of my solution. I'm going to do the same thing with 2. So I have 2 minus 1, 2 plus 4, 2 minus 3. This is going to give me 1 times 6 times -1. My result here and my product is a -6. Okay. And so that means that this part of my interval is going to work. And so I can shade this part if I want to. Somebody is probably contemplating, well, if I get the first one and the second one, can I just say they alternate? You can, but if you made a mistake, you'll never find it. Okay, so it doesn't take that much longer to check 4 as opposed to 2. I would always double check and make sure that it works like that. Okay, because it's super easy to make careless mistakes. All right, so this last one, I'm going to have 5 minus 1, 5 plus 4, and 5 minus 3. And this is going to be 4 times 9 times 2. And that's going to be a positive 72. I don't want positive. I don't want numbers which give me a positive product. And so now I see that there are 2 pieces of this, 2 of these possible solutions that work, and that's negative infinity to -4, and then 1 to 3. And these are my solution intervals. questions?
Why did the in the green the so the why are they positive but change to different signs when you put them in possible solutions?
Okay. So these, you mean from this line that I'm pointing to this line?
No, ma'am. From wait,
So I put my numbers here, and then I think I used the same numbers unless I made a mistake. Sometimes I do understand.
oh, like when you're doing the test points, why are they different?
So why am I using these different numbers up here?
No, man. Like when you're what you're minus subtracting or adding the test points by, why are those different? Why are their signs changed?
So why am I getting these numbers? Where am I getting these signs?
No, I'm like when you're doing the math to get like negative 48, 12, and 6, why is there a plus 4, but in your possible solutions it was a negative 4?
I gotcha. I'm with you. I am actually going back and plugging this number into this polynomial. So I'm plugging it in for x here. So I have a -5 and then -1, and then my -5 is going in here, +4. So I'm going back to my original problem and plugging in that x and doing whatever it says to do.
Oh, okay.
Does that make sense? That's a really good question, but does that make sense now?
Yes, ma'am.
Okay. Sometimes it just takes me a while to figure out what your question is. It's just me, so it's not you. So, right. That's a really good question, though, Justin. Thank you. All right. Anybody else? Okay. So we've got one more of these. I want to point this out to you again. This one said 0 over here on the right side. This one had 0 over here on the right side. Guess what we're not going to have on this last one? We're not going to have 0 on the right side. Okay. This is quadratic, and so the first thing I have to do is I have to move the 6, so I have 0 over here on the right-hand side. In order to solve these, I have to have 0 on the right-hand side, period, okay? So before I do anything else, I'm going to rewrite this as x squared minus x minus 6 is greater than or equal to 0, okay? Now, every other problem we've looked at had a product here. So before I do anything else, I'm actually going to factor this, okay? And it's still going to be greater than or equal to 0. And so this polynomial is going to factor into x minus 3 times x plus 2, okay? That's step number 1. That's an extra step that we haven't had before, but you have to do this, okay? Now, notice it says greater than 0. And so this means that I need positive products for my solution. Right? Right? So the first thing I do at this point is I find those boundary points. And I find my boundary points by taking x minus 3 times x plus 2 and setting it equal to 0. And I'm going to take each factor and set each factor equal to 0. And I'm going to find my boundary points of 3 and -2. That -2 is going to go first on my number line. 3 is going to go second. This one is back like the first one of these we did, where I'm just going to have 3 possible solution intervals. And so my possible solution intervals here are going to be negative infinity to negative 2. Round or square bracket?
Square.
Square. Excellent. Well, I love it when people answer at once. And so I'm going to go negative 2 to 3. And then 3 to infinity. Square because of the equal sign on here. No other reason for that than that. So now we're going to look for our test points. My test points, I'm going to use negative 3, 0, and 4. I love using 0 if 0 is a possibility. So my test points, negative 3, 0, and 4. Notice that I'm going to plug them into x minus 3 times x plus 2, okay? Remember, I need that product to be positive, but I'm going back to that factored form. That's where I got my boundary points from, and so that's what I'm going to use in order to, never mind, my brain just stopped, sorry. That's what I'm going to use, that where I got my boundary points from. That's the product I'm going to use to plug in my test points, okay? All right, so I'm going to plug these in. So I have negative 3 for my x minus 3, and then negative 3 for my x plus 2. This is going to give me negative 6 times negative 1, and that's going to give me a positive 6. Okay. Is this interval going to work for me or not? Yes or no? Everybody answer me at once. Is a positive product what I want or not? Yes, excellent. Thank you. Okay, so this one is going to work. So this is going to be a yes one. So that's going to be a good one. So let's go ahead and shade that. Shaded this direction. This part is going to be good. Excellent. Okay. I don't either. Okay, so then we're going to go with 0. So I have 0 minus 3. I have 0 plus 2. This is going to be a negative 1 times a positive 2. And this is going to give me a negative 2. Negative is not good. I want positive in this problem, so this is not part of my solution. And then finally, I'm going to have 4. Plug it in for x. 4 minus 3. 4 plus 2. And so this is going to be positive 1 times positive 6. And so I get a positive. We've already established that positive is good. So I'm going to shade everything this direction. That means that this one is a good interval. And so my solution could possibly just be 1, but if it is 2 pieces, I am going to be separating them with that union symbol, okay? So if it turns out it's just one solution, like just this number in here, this interval in there, then I wouldn't have anything except that solution. That was terrible, sorry. I'm gonna clean this up. All right. Questions? Y'all exhausted now? I'm exhausted. Okay, so this finishes all the material for homework and quiz number 3. I know it was a lot, okay? I told you we were going to push, but we're slowing down just a little bit. It's going to be better. We'll get through this and things will be good. So we'll slow down just a tiny bit here. So. All right. So I know some of y'all have gotten kicked on and off, and I'm not sure I don't know if you live like where I live, the weather could be affecting your internet and all kinds of crazy things like that. So I will try to hopefully, I'm going to see, and maybe I recorded this, and hopefully